So I have been putting off ordering some these guys, whatever these things are called, some of these dudes, because they're kind of spendy for what they are. I've got a bunch of these that are copper, but they're a bit too small. As fate would have it, though, yesterday, I don't even know if this is gonna fit in frame here. I don't think I have enough desk. Somebody gave me this big weird thing. Look at all these headway cells. Look at these giant resistors in a relay. So I have no idea what this thing is. I have no idea where it came from. Um, and this is the first time I've looked at it. I mean, I've looked at it, but I've been not looking at it. But I figure at the very least, I have a bunch of the proper sized bus bars. So that's super cool. But anyway, let's get a look at this thing. I mean, I'm guessing based on the balance looking ports here that this is a BMS. And based on those big ass resistors, I'm guessing they're they're burning off energy so that this thing can be charged quickly, I guess. I don't know. I don't know. I really don't know. I just think this thing's really weird. Sorry, my picture's all blown out. It's not much I can really do here. So, zero, what? 0 volts. Whoa. I'd say, oh, you know what? Maybe I'm not getting a good connection here. No. Oh, there we go. 1.1. Okay, at least we're consistent. This is, this is not looking good. These, yeah, these balance leads are just huge. Wow. There we go. 1.1. Okay, so everybody's just really low so far. It's really, it really, the way these are wired, it really is making it goofy to check here. But I'd say already Outlook is not so good. Yeah, 1.1. So I'm guessing purely just out of my ass, just guessing, that we've got a charging port and a power port. A 30 amp relay. And I mean, this right here looks like all the normal. Ooh. Oh, here we go. Maybe this is what happened. Does it look a little bit toast? It sure does to me. I guess we can check those. Man, they look better on camera than they do in real life. That trace is gone, isn't it? Ugh. So I don't think the resistors actually went. I don't think this little dude could pull enough power. Hang on, let me adjust my camera here. One sec. There we go. So we're gonna exchange quality for light quality with the digital WDR. Uh, anyway, that looks pretty fried. The trace looks fried right there. But I also wouldn't think that this little dude, that guy right there, I wouldn't think he's able to pull enough power to do all that damage without self-destructing himself. So I'm wondering if somebody shorted this thing, you know? That's what I start to wonder. I'm gonna check the I'm gonna ohm out these resistors here. Are these all the same? 3R9, 3R, yeah. So let's see what this one does. Uh, 3.9 ohms. Well, that kind of adds up, doesn't it? There's like stuff all over the other one. It was hard to get a reading. 3.9. 3.9. 3.9. Yeah, so I don't these guys didn't get fried. I think just that trace next to him. 7.6. So I am confused here because I guess in a normal style BMS, I would expect, this style to be some sort of bleed off resistor. So what the heck are these huge bleed off resistors? Or, what is this huge resistor network here? That's just crazy. What are you doing? 50 watt. There's some 50-watt dudes. 3 ohm also. And then you've got, giant versions of those. This is so weird. I just think this is like a weird system. Maybe it's obvious to everyone else exactly why this BMS looks this way, but I'm not familiar with that dude. Or that guy. Or that guy. None of these chips, I don't know any of these off the top of my head. This is providing power. Power, power, power. Running that relay probably. And then what's going on over here? It's almost like you're getting some artifacting from the WDR, but these whatever was here is broken out on the side here. So maybe that was maybe these guys were slapped together in parallel or in series, I mean. That's just a big old plane there. Huh. And I see some stuff there. Okay. That battery looks like it gave up the ghost. Ugh. And or water got in here or something. That's awfully corrosive looking. That dude's about corroded off. Which battery do you think it was? The one in the end there? I've never seen one of these headway cells leak, but you know, that doesn't mean anything. Yeah, I need to tear all this off to get a look. It's funny how my camera has more color when it's out of focus there. Doo-doo-doo. I'm in my jammy jams. So, I don't know. Does this thing look like it was built for success here? Why did that trace blow? And how viable are some of these cells, I wonder? It's very, very interesting. I'm just going to check real quick and see if there's any uh, voltage on the output here. It is. Is this a normally closed relay or a normally open relay? Oh yeah, we got some real heat over here too. Like, yeah, these MOSFETs got real hot. They baked the board. Anyway, there's a lot of good parts on this thing, regardless. So I'm excited to have it. We've got a total of 12 headway cells. These are all in series, aren't they? Yeah, these are all in series. I guess, yeah, 12P. So is that essentially a 48 volt system? So maybe this came out of some super strange telco, and then they're stacked in parallel, and then maybe the cooking here happened because that first cell failed, right? And it essentially, well, that kind of doesn't make sense to me because I'm a little bit confused about these giant resistors and what their role is. I guess possibly these are just current sensing resistors. That's they're being no, they're the they gotta be for bleeding off stuff. So it kind of doesn't make sense then that this guy would have self-destructed if this guy was low, because I would think, well, unless his voltage shot up and then this just stayed open and cooked it. I'm not seeing where any of this could deliver the amount of current though that it would have taken to get those guys really hot. But maybe it's through a via here or something. Uh, yeah, I don't know. If anybody has any theories, I'd love to know. And I think, well, given the state of this thing, okay, actually, we'll just work our way down this connector. Horrible. Terrible. Also terrible. Also terrible. 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 So, if all these were able to go down this dead, because I mean, it just looks like this thing was sucked dry, and that's the last one. So, kind of, to me, it appears this battery and this battery are just totally, totally in horrible condition. Wait, that's 1.3. All right, am I an idiot here? We go from here. Yeah. It's nice copper right there. Yeah, that's no good. What about this one? Okay. Huh. You think that could have helped with this failure scenario? Oh, that is the wire that I was like, oh, hey, it's not connected. Oh, oh. How you doing? Is that the total run of the wire? All right, I'm gonna let's get this undone. Sorry, I know my camera's all blown out. There's nothing I can do about it. Well, I'm sure there is, but I'm not gonna do anything about it. We do not have the technology. I mean, I just want to make sure there is a wire in here, or I would like to see if it was just not even, not even clamped. We're going full in macro mode here. Yeah, I see wire in there. Ooh. So the crimp action we're looking at there is likely from being held down in the connector. Doesn't look doesn't look too crazy. I mean, it doesn't look like somebody fat fingered the putting on of the ferrule. Uh, but I have to wonder if this was sort of the cause. I'm still not understanding though why the balance resistors would have gone completely nuts. Okay, enhance. Do we see any kind of what I was looking for is something unnatural and green. Maybe. Maybe. Think that thing rotted off? All the copper right here looks really good. That is copper. Just not on my camera. It's I don't know. I don't think I pulled this off myself. Yeah. So anyway, that's what we have. So now I guess the question is, why did the whole pack get pulled so low? I wonder if it's possible the relay stuck. So let's think about this. So over here, everything's marked power supply over here. And then this is marked out. And this could just be a backup module, in which case the power supply is running the show and maybe fails over. This is just a single doodad, but I kind of want to know. I wonder if that relay is kind of stuck. You know, or if the whole thing was just pulling too much current, because maybe it's these MOSFETs. And I'm sorry, I can't reverse engineer a circuit, but right here it kind of seems like, okay, these MOSFETs are in charge of supplying what to me looks like power, right? And then when we lose power over here, I assume you would cut these off. And so they're probably hot because they were just running. You know, they were just shorted the whole time, 90% of the time, providing power. And then what else do we have going on here? Can you smell the gear burning in my head? I'm just trying to think through this logically. So yeah, like I am thinking this just like your normal 12S balance board. But then what the fuck is going on over here? Why would you need all these giant resistors? Is that because these were stacked and, you know, with this missing board, these dudes were stacked in parallel, and so you limit them through a resistor, and you also have the ability to shut them off. 1, 2, 3, 4, 5, 6. Dude. So they can dump battery in here and also here. But then also they've got this relay that kind of looks like it's going here. Is that dust or is that a bead? Oh yeah, let's get in there and short it. That's brilliant. All right. Yeah, so somebody explain to me, please, what these giant resistors are doing besides going into my collection of giant resistors. Those will be super handy. Um, Hooked up to the same place. Yeah, they're totally all in parallel. So I don't know what that, let's see if that goes anywhere. So I'm just grabbing this bus, right? And these are all parallel. And they're going to positive. I'll admit I'm a little confused here, but then again, I've been confused before. Enclosure, and I'm pulling all this out of my ass. And what's also weird to me a little bit is that these guys really probably were on all the time, right? That was short. That was common too. Uh, huh. I'm gonna look up that MOSFET and yeah, I'm gonna read something, see if I can get smarter. Excuse me, ultra fast recovery diode. What? Okay. So everybody's contributing to output then. So it is it's just a diode. It's just a diode. Just a diode that's been running hot. So, okay. I think these just ran hot because typically the power supply is supplying current at the same time the battery can also supply to the output. So there's no switching or anything. Okay. I think the squirrel in my the squirrel that runs the small wheel inside my head is just getting tired. Okay, so then in terms of charging, do we think the relay is just doing the charging? It's just sized a little small? Because something needs to take what is presumably the higher voltage off this power supply and get it into the battery, right? It's not going to push through these diodes, so it probably goes through this relay. Look how loose that guy is too. Man, that's just shoddy right there. Somebody could have taken that off. All right, yeah. So anyway, plan A, steal all the parts. Oh, I will say I just did some remedial math. Nobody yelled at me when I said this was probably telco 48 volt system. I don't know what the hell this thing ran. If anybody has any ideas, let me know. Cause yeah, I just got to thinking about it. I'm like, 4 is a 12 volt. It says 12, 24, 36. 36 volt system. So what's your best guess as to what this thing probably did? And what's your best guess for why it didn't? All right, see us. So these are copper. They probably are standard headway bus bars too. I think they just stuck this in a jig and beat it into this circle. It is actually bent, or this arc is real. 'Cause you can see it sort of Meh. It's a little meh. So I'm guessing that's what they did. And anyway, I figured if anybody watched my video at all, they can watch me tear this stupid thing down too. Let's sit here and narrate. Try not to explode the world. I'm just doing this. Whoa, that's a bad idea. I'm doing the ends first, one-handed. Oh, the crust. The crust is real. Now that's from that connector though, mostly. I don't even think that's from the cell. Uh, there is some nasty there though. That used to be black, right? Okay, so let me just grab another cell. Am I stupid? I used to be able to imagine things in my head really well. Oh yeah. No, they would both be getting tighter if you tighten it. They don't need to be reverse threaded. You idiot. You idiot. See? You can get them nice and tight, just like I was saying. I didn't have that backwards at all. I definitely know what I'm talking about. The logic is strong with this one. He just intuits what circuits do, but doesn't actually figure it out. Like YouTube researcher. I've been researching on YouTube and all those churches are mudslides or something. Mm-hmm. And yeah. So, why did these get pulled so low then? Also, huh? Why would that have happened? I guess nothing would protect them. There's no off switch. If these are just diodes, it'll just diode until it's diode. So, like, this isn't a good design philosophy, really. If you can't remove the load, these batteries are just going to go until they're completely toast, right? I mean, I got that part right, right? If these are diodes and you have no power supply, this battery is just going to drain if there's a load until dead. There's, there's like, so you've got some attempt at managing the charging, but that's only assuming that, well, you can't, I guess you can remove, yeah, you can remove the pack from presumably the higher voltage here. Meh. It's just, I don't know, it's a little bit weird. I would think you'd want to be able to disconnect the battery so that you could really uh, deal with its charging scenario. But then again, I guess you don't want the failover mechanism to have smarts behind it because that can fail too. I don't know. It just seems, I don't know. I don't design, I don't know how to design anything, but meh. Either way though, I think if this were under a load, it's gonna give it until these batteries are destroyed. And that's, kind of a pointless design because the device that you're trying to keep going is still going to turn off, and then you're just going to also destroy the batteries, you know? So, eh, not, I'm not terribly impressed, I guess, you know. And then yeah, I guess this really gave up the ghost here. So this has probably got some nasty shit in it, unless these really did get wet. That corrosion is a little weird. That corrosion is a little weird, man. Do you think? Oh, do you think somebody really torqued it too much? Jesus. I'm gonna put some pressure on that guy and see if I can. Nope. Those aren't that one's not gonna come apart. That is quite suspect to me also. I'm gonna say this is some shoddy shit. You can't just, torque. You can't put the gorilla on these. Oh yeah. I mean, this is definitely battery shit that's all over my hands here. And yet this guy still seems okay, but I imagine if I keep twisting, he won't be. Should I just keep twisting? Because as far as I know, there's going to be, some copper foil that is going from this end connection to the battery. So if I keep twisting, it's going to devastate that foil. Man, that's weird. That's weird. This is going to get the cut. I'm going to take that out to the shop before I go undoing it. I've not witnessed these things fail, so this is the first for me. Again, I apologize. Everything is so blown out and artifacty. Yeah. I I doubt anything's going to be salvageable. I mean, that is it. I'll see about charging some of these, see if any of them come back, and do some tests on them. But I'd say Outlook is not good. So I guess you could say this video is sponsored by Central Battery because they save all this shit for me because they know I like to have it, and they're awesome, super awesome. I'm afraid of this. I'm afraid of it. Was this one of the ones that was low? Okay, let's stop. So you just leave crap lying around on your desk long enough, and you've just got baggies nearby. So I've cleaned up all the cells that I think I'm going to keep. Um, this one is definitely toast at 400 millivolts. This one is certainly suspect in that it's turning. And what was I gonna do here? Oh, I wanted to grab these resistors, which you can't see. Well, let's see if we can get this. I don't think it's gonna get this. My little snippers could barely cut this, so I don't know where my big snippers are. No way. Nothing is happening. Okay, turning off the Ryobi. And yeah, look at all my loot. Some 50 waters. What should I do with these? Butamus. Ah, I should probably keep those screws too. Ah, damn you. Should have just taken the board off in the first place. Um, Sitting here thinking, I want to build a new 12 volt pack, and I could just cut this right here, clamshell this together, and you've practically got a case for a 12 volt pack. So rather than print a case, which I never did, uh, if you've looked at my 5-year review, I guess I did have a case on it for a while, but right now I'm just carrying that pack around open and jumping cars and stuff, and it's really dumb. And I don't know, but should I just cut this down the middle and then clam it and instant headway cell holder? Or should I print something? Alright, that's it. That's it. Everyone stay safe, have fun, do things, enjoy your time off. If you're off, there's nothing you can do about it. Um, I'm job searching. Uh, I know it's tough, but just everybody do the best they can, and whatever. We're all in it together.